Hey all, welcome back to my channel. If you are new to this channel, consider subscribing this channel and hit on the notification bell so that as soon as I'll be releasing the video, you'll getting the notification. And also follow me on LinkedIn where I'll be providing the slides or presentations for the particular concepts that I'm explaining in the YouTube. Okay. So let us not waste any more time, and today we are going to discuss about how to write a test bench in Verilog. So before knowing how to write a test bench in Verilog, first we have to know what is test bench and what are its uses in Verilog. So basically test bench is nothing but it is an environment where we will be checking the functional correctness of our design. Okay, basically how this will be happening is, so in the starting I have told about like what is front end and what is back end, is it or not? So here how the design process will be going means, for example we want to create a design. Okay, so what will we be having, we'll be having some specifications in order to create a design. Like I want the design which will be taking these inputs, and I want this output. So certainly it should have this features, these features. So combining all these features we will be writing a code, and that is called as RTL code, nothing but register transfer level code. That means this is the work of the designer. Okay, the designer will be writing the code like Verilog code. So now what happens, now comes the work of verification engineer. So what does the verification engineer do means, he will be verifying my code. Okay, that means he will be sending some stimulus means nothing but stream of data. Okay, in order to check my design code, what he will be doing, he will be sending some data, and that data will be working on my design. After the verification engineer sends some data, and after the working is done, after the monitoring is done, if there is bugs in my particular design, then the verification engineer again sends it to the design person, and then the person will be rectifying the Verilog code, and then this process will be continued until my RTL code is bug free. That means until my RTL code doesn't have any bugs, this entire process like design verification will be continuing, and then after my code is bug free, then that is sent to the backend where backend engineers will be doing it in the physical form. Okay, basically this is how the process is. So in this year, this verification engineer, as I told you, how he will be verifying, he will be writing the test bench code for my design. Okay, he will be verifying the test bench, he will be writing the test bench code, and then from there he will be sending the stimulus. Okay, so this is how basically the verification process is being done in front end VLSI. So in this process, this test bench is nothing but it is an environment which will be uh, like the environment which will be okay, to check the functional correctness of behavior. Okay, and then here the connections between design and test bench are established using a port interface. So in order to design the my particular, that means in order to check my RTL code, there should be some connection between test bench and DUT. Is it or not? So basically this connection between test bench and DUT is nothing but a connecting the interface. So here as I told you, the test bench generates and drives a stimulus to the design to check its behavior. That's what I told you. So what will the test bench do? It will be generating some stimulus is nothing but some group of data. Okay, that data will be sent to DUT, and that stimulus will be processed there, and it will be checking my particular RTL code. So this particular place where we'll be writing the RTL code on that device is called as design under test, DUT, or it can also be called as UUT. Okay, DUT means design under test, or you can also call it as UUT, nothing but unit under test. Okay, clear? So this is how you will be writing, like this is what the test bench is. And now when it comes to this is the test bench structure. If you see here, this is my verilog test bench. So here if you see, in this is the test bench. That means this is, as I already told you, test bench is nothing but it is the environment where we will be testing our DUT. Okay, so how you will be testing here? You will be sending the stimulus. Okay, if you see here, this is my stimulus, nothing but group of data, and it will be sent to the DUT, and then again the process will be monitored in the test bench. Okay, so this is how basically the test bench working is done. Now let us see how are we going to write a test bench code. Okay, so if you see here, this is my test bench code. This is my RTL and this is my TB. Okay, RTL code. Nothing but this is my DUT, design and test. Okay, and then this is the TB for this DUT. Okay, now if you see in this basic program, okay, I don't need to explain about the RTL because we have already know about this how are we going to write a RTL code. Okay, basics, not about the logic but the syntaxes and all, like module and module. Okay, it is a full adder, and then what does the full adder contain? It contains three inputs, okay, two outputs like A, B, C. These are input ports, and sum and carry, which is output port, and some logic for my full adder, and then end module. Okay, this is my basic RTL code. Now for this RTL, if we are going to write a test bench, how are we going to do it? So have you seen some important thing here, like everything will be written within module and end module. Okay, now if you have seen here, there is no input or output ports here, only ridge and wire. Okay, so why is it? Because basically if you see in the thing, it is just generating the stimulus and it is sending it to DUT. Okay, that's it. There is no need of any inputs or outputs here. Okay, there is no need of port connections here. Here we only use either ridge or wire connections. Okay, either to hold the value or to drive the value. That is the work of test bench. Okay, what does it do? It will be holding the value or it will be driving the value to DUT. So that is why there are only wire and ridge data types. And then if you see here, this is the connection for TB and TB and RTL. Okay, and this is how the stimulus generation will be done. This is called stimulus means nothing but a group of data. Like this is one stimulus, this is another stimulus is nothing but data that you want to send into this particular logic. Okay, so this is how basically your TB code consists of. That's it. Now let us see one by one. So first coming to rich data type and then the wire data type. If you see the inputs here, these inputs are similar to the inputs of the RTL code. Okay, you can give same inputs or else you can give the different. You can give same input names in test bench also, or you can give like different, like A TB, comma B of TB, comma C in of TB. You can also give it like this. There is no issue like you should give the same names and all. Okay, in the same way for this also, like sum TB, comma carry TB. Right? So now if you see the region wire here, the input values are considered as reg here in test bench. Okay, and the output ports are considered as wire in test bench. Okay, so now here comes the issue. What is that? So in the previous classes I already told you that input ports and in-out ports also will never be considered as rich. Is it or not? And output port can be rich, right? So but when it comes to like test bench, this is for RTL. Okay, now when this comes to test bench code of the same full adder, what happens means this entire thing will be reversed. That means all the input ports are considered as rich and output port is considered as wire. Okay, so just remember this. I'll be telling you what is the reason behind it. Okay, so as for now, you just remember that every input port from RTL is given as reg in TB, and every output port in RTL is given as wire in TB. Okay, so now I'll be explaining you what is the reason behind it. So just see this particular pictorial representation here. So stimulus, it is nothing but test bench, is it or not? So stimulus means nothing but this is our stimulus, is it or not? Right? So this is my stimulus. Now if you go to this pictorial representation, stimulus is giving the input to DUT, is it or not? So from stimulus it is getting, like from test bench it is giving this stimulus to this RTL. That means what is that? This is giving means in the sense it is output, is it or not? So if you see the here, this is my test bench and this test bench is giving the output. So when this comes to output is nothing but output will be taken as reg. So that is why the ABC are considered as reg. Okay, and now what is happening? Now in the design and the test, in the logic, all these ABC stimulus values are being placed and they are working out, and then again they are giving it back to test bench where the monitor will be there. Okay, now what does the monitor do? It will be monitoring every changes that are given from our DUT. Okay, now that means what is happening here? DUT is giving the output and this is taking the input. Okay, this test bench is taking the input. So when it comes to input, it should be wire, is it or not? So that is why basically in test bench input ports are considered as reg and output ports are considered as wire. Okay, I hope you got the difference, like why this is considered as reg and wire. If you still didn't get like what is why is this considered as this, just comment me so that if you have any doubts regarding that also I'll be making it clear. So as for now, this is the reason why basically in TL, input and output are wire and reg, whereas in TB, input is reg and output is wire. Okay, so now this is the thing here. So this is about reg and wire, and now comes for mapping. Okay, what is this mapping? So mapping is nothing but, if you see in this pictorial representation, stimulus is going to DUT and DUT is giving some to again test bench. So there should be a connection here in order to give it like this, is it or not? In order to for the test bench to send the stimulus and the design and the test to work on the stimulus and give the output, there should be some connection, is it or not? This connection is this mapping. Okay, this is my mapping. If you see here, this is nothing but instantiation. That is what during the module instantiation I have already told you. Instantiation, that means communicating. Okay, instantiation is generally this input output ports are used for communicating between test mentioned module RTLs. Okay, what is this here? Actually, if you see here, this full adder S is nothing but the RTL's module name. Okay, now I am instantiating it, nothing but I am creating a copy for this full adder S. Okay, so I can give any name like UUT, DUT, anything, any name you can give, but basically, as I already told you, in order to make it understanding to everyone, basically you will be giving either UUT or DUT. Why? Because UUT means unit under test or DUT, design under test, both are same only. Okay, full adder yes, UUT, and if you see here A, B, C in some carry. What is this? This is mapping by order. So that is why, since this is mapping by order, as it is like what is the order in which you are defining it here, in the same order you are defining it here. Okay, for example, if it is not like, if it is not Just a second. Yes, if it is not like this, like if it is not, if you don't want to connect it in order, then you can connect it by name. Then how you are going to do it? For example, let us do this same here, right? Okay, now I can write it as module full adder TB. Okay, register. I don't want to give the same names. Then what I can give? I can give any name. Okay, BT no TB. Now wire of sum of TB, carry of TB. Okay, now comes the instantiation. For instantiation, what I am doing, like full adder is UUT. Now what happens? Here comes dot A of, what is this? A is nothing but the RTL input. Dot A of ATB. Okay, dot C of C in TB. Dot B of BTB. Dot carry of carry TB. Dot sum of sum TB. Okay, so this is how you will be writing the instantiation if you follow it by port by name. Okay, if you see in this port by name, you just didn't follow any order. First you have written A, then C, then B, then carry, then sum. Okay, in the any order you can follow. Okay, but if this is possible only if you are going by port by name, and in this port by name first you have to give dot. Okay, and after dot you should be giving what is there in input, and then what is the name that is there in test bench. Okay, if you don't want this, if you want to follow the order, then you have to follow the same order that you have given in the parent module or RTN module. Got my point? So this is about the instantiation. So what you have done here, you have just written rich wire data types and then instantiation, and now then comes the initial begin. Initial means basically in test bench every stimulus is given only once. Okay, that means this is only possible, like if it should be given only once, then it should be possible by writing initial block. Okay, you will be learning about this initial blocks in the further sessions, but as for now remember that generally in test bench whatever stimulus you want to give, you will be given within initial. Okay, and then if the initial block contains more than one number of lines, then you should give it between begin and end. Got my point? Yes, if there is only one stimulus, then you can just write initial and you can just give the stimulus, and then you can end it with end module. But if you are having multiple stimulus like this, see, if you are having multiple stimulus, so if there are multiple stimulus, it should be between begin and then end module. Here comes the end module. Got my point? So this is stimulus. Stimulus is nothing but, for example, if you see here, this is my full adder circuit, is it or not? So this is my stimulus. Okay, stimulus is nothing but these two values I'll be giving it. If you see here, see, 0 0 0 0 0 0 1 0 1 0. Okay, this is data that you are giving. Why you are giving this data? In order to check whether the logic you have written is correct or not, or whether it is producing the correct output or not. So how it will be seen? Now comes the point. Okay, you have given the stimulus, it is working. Then how are you able to see it? How are you going to see it? It is done by using $monitor. Okay, this is the system task in verilog. Okay, you'll be learning about system task later, but $monitor is just used to, like it is used to yes, monitor the output whenever there is changes in any stimulus, or whenever there is changes in input as well as output, it will be monitoring and it will be displaying on the log file of your verilog system. Got my point? So this is about verilog, right? Okay, this is how you will be writing the steps involved in writing verilog. See, declare a test bench, nothing but declare module. Anything you want to write, first write within module and a module, and then declare set signals that have to be driven to DUT. for which signals you want to drive to DUT, those signals first declare it, and then instantiate top level design and connect DUT port. That means you should be instantiating it with the top level. Top level is nothing but the RTL code where the first module is there, that is called top module. You should instantiate it with DUT or UUT. Okay, and then use an initial block to set variable values. See, you are using initial block in order to set the values, and then comes an always blocks can also be used to perform certain actions throughout the simulation. That means when you want to perform a particular task for many number of times, okay, when you want to simulate that particular task for any many number of times, then you can go for always block. But mostly, as I told you, any simulation is done only once. But if you want to make it, like if you want to customize it like that, so basically then comes the always block. But mostly in test bench, at the basic level, everyone will be using only initial block. Okay, so now what is the syntax of your TB? Like what should your TB contain? What should your TB code contain when you are writing TB for combinational circuits? Okay, so basically both combinational circuits and sequential circuits are same thing. Like TB is same for both of them, but in combinational circuits the thing is you don't have clock. Is it or not? Whereas in sequential circuit you will be having clock and reset. So that is why basically clock and reset will be present in sequential circuits, and in combination circuits there won't be any clock or reset. Okay, so see, what are the things that you need to know in order to write the test bench. Okay, module, end module, and within this module input output declaration, nothing but wire or ridge declaration, and then instantiation, we have already seen it. See, this is input output declaration and then instantiation, and then comes initial block. See, within the initial block you will be writing all the stimulus. See, within the initial block, within begin end, you will be initializing, nothing but you will be sending the stimulus. And for example, when, as I already told you, when this stimulus is lot, like if this is only, since it is only full adder basically, right? So what happens, it's only full adder, so it is having like 2 power 3 8. It is fine. Now for example, if you are adding 4-bit full adder or else like that, now what happens? 2 power 4 32. That means you have to manually give 32 inputs. But is it possible to manually give 32 outputs? No. So basically in such cases what you will do, you will go for loops. Okay, like for loop, okay, while loop and all. So for that also, like initial begin, and then you will be writing the loops. If there is no like if there are no such these things, then you will use for or while loops, and then initial begin, monitor. Okay, within initial begin, monitor. Okay, monitor block you will be writing. In this monitor block you will be monitoring all the values like A, B, C in sum, carry. Okay, if you see, this is percentage B. Okay, I think you know about this standardizations, like in C or any other language also you will see, like percentage B is for binary values, and percentage D for decimal, percentage H for hexadecimal, percentage O for octal, percentage F for floating like real numbers, okay, percentage S for string. Is it or not? And here percentage T for time. That means in order to know the simulation time. Okay, dollar time also you can give it. Okay, I think we have already discussed about this dollar time in data types. You can go there and check it out. Okay, so this is how you will be giving, like A equal to percentage B equal to all the things, and A, B, C in sum carry. So any change in any of these values, the monitor will be activated and it will be displayed on the log file. Got my point? So this is how basically for combinational circuit. Then for sequential circuit also everything is same. See, module, declarations, instantiation. Until here everything is same. Now one more initial block will be added where the clock is generated. That's it. Okay, see here, initialization, loops, monitor, everything is same. One more thing that is added is clock generation. See, this is for example JK flip flop. Okay, see, this is JK flip-flop. It is having JK clock and output as QQB, and then initialization is done. Okay, initial begin clock. See, clock value is 1 tick be 0, and then forever means until and unless we stop the simulation, the clock will be running. Now what is the logic that I am giving? For every 5 unit time delay, the clock should be negation of clock. That means when this clock value is 1 at 5, then at 10 it should be 0. Okay, and again at 11, 15 it should be 1. Again at 20 it should be 0. Again at 25 it should be 1. That means what is it? The clock cycle delay is given for every 5 seconds. Okay, in this way the clock cycle value is forever, like it will be jumping from 1 to 0, 0 to 1, 0 to 0, toggling from 1 to 0, 0 to 1, and then you will be generating the stimulus, like see J K. Okay, you will be generating the stimulus, some particular stimulus, and then within initial begin again monitor and end module. Simple. Okay, so if you see here, for every begin you are writing, you should end it as soon as you have completed that particular block. Okay, this initial begin and end, again initial begin and again initial begin end. Okay, again initial begin and end module. Got my point? So this is how basically you will be writing a test bench. Now let us see a small like a basic example by using a 2 by 1 mux. See, module mux, fine, and then since mux, what does the 2 by 1 mux consist of? Two inputs, one output, one selection line, and right or not? I naught, I1, selection, and Y. Okay. So since these two are inputs, they are rich, and selection is also input, so that is also rich, and then Y is wire. So now instantiation, that means you have written RTL somewhere. Okay, now you are instantiating it, nothing but you are mapping it with test bench. Mux 2 by 1. Okay, this is my mux. You can write it as DUT, anything like UUT or mux, anything. But as I told you, it is better to write like DUT or UUT. Okay, and then if you see selection I0, I1, Y. Okay, now if you see here selection I0, I1, Y, the why this is given as like this means maybe in my RTL code I have written it as like input selection I0, I1, okay, and output is Y. So that is why what is happening in the same order I am giving it here. Okay, and then initial begin end. Within initial begin end, what is it? First I will be giving the stimulus. Okay, you can either combine all the monitor block and everything here itself, or else if this is not the case, since you are a beginner, it's not correct for you to write in this way. Basically what you will do is within initial begin you first send the stimulus, like I0 is 0, I1 is 0, and selection is 0, and after hash icon selection will be 1. Okay, and then end, and then again here you write another initial block and then write the dollar monitor block here. Okay, and then end the module. Got my point? This is how you will be writing a basic programs in test bench. So that is all for today. Okay, so this is how you will be writing the test bench code. If you have any doubts regarding the test bench code and all, just pin me in the comment box and I'll be replying you. Okay, also follow me on LinkedIn where I'll be giving the slides for this particular presentation. Okay, thank you.